So today we're going to be solving a problem. We're going to be solving an AMC 12B problem from 2009 using the angle bisector theorem that we learned about in the previous video. So hope you remember what this theorem is, and if you forgot, then just refer to the previous video and then come back to solve this problem. So this problem, it involves the angle bisector theorem. So let's read this problem first. So trapezoid ABCD has AD parallel to BC and BD equal to 1. So let's just draw this. Let's just draw this trapezium out. So I have this diagram. I have this diagram already because I just felt that it would take a long time to draw it. So let's label the points first. So that'll be A, B, C, and D. And then we have that AD is parallel to BC. AD is parallel to BC. And BD is equal to 1. Let's keep that in mind. And DBA, angle DBA is equal to 23 degrees. So let's draw a line. Let's connect B and D. Connect B and D. Okay, never mind. No, it's not perfect, but so angle BDC is equal to angle DBA is equal to 23 degrees. Angle DBA is equal to 23 degrees. And angle BDC is equal to 46 degrees. Angle BDC is equal to 46 degrees. 46 degrees. And the ratio of BC to AD is equal to 9 to 5. The ratio of BC to AD is equal to 9 to 5. So keep that in mind too. So the question is asking for the length of line segment CD. Line segment CD. So first, let's observe this diagram closely first before we start. So we see that we have two known angles given by the problem, which is 23 degrees and 46 degrees. And what we notice about this is that 46 is double 23, or 23 is half the value of 46. And angle bisector and the angle bisector theorem are about angle bisectors. So it's about having angles and dividing angles in half and and bisecting angles. So we kind of get a clue that this might have something to do with the angle bisector theorem. So we got a clue about using this theorem. So let's start solving this problem then. So firstly, we're going to draw a line that is parallel to AB and passes through D. So let's put that in pink. And we're going to draw a line that passes through D and is parallel to AB. So about like that. Yeah, that's good. And this is parallel to this. Oh, and let's label this point E. So line DE is not equal to line DE is parallel to line AB. So ABED is a parallelogram. Okay. And then we see that angle DBA and angle BDE are alternate angles. So they're equal. So angle DBA is equal to angle BDE. So basically angle BDE is equal to 23 degrees. Is equal to 23 degrees here. Okay, just remember that 46 degrees is denoting the measure of angle BDC, not this angle. So 46 is the measure of this entire angle. So just keep that in mind. And we can find the measure of angle CDE, which is basically angle BDC minus angle BDE, which is 46 minus 23 equals 23. So now we see something interesting. So the measure of angle BDE is equal to the measure of angle CDE. So DE, line segment DE, is an angle bisector of the angle BDC. Let's write that down. So DE is the bisector is the bisector of angle BDC. Okay. Now we found an angle bisector in triangle BDC. We found an angle bisector of one of the interior angles of triangle BDC. So we can use the angle bisector theorem to find some unknown values here. So by the angle bisector theorem applied in triangle BDC, we see that the ratio of CD of this to this is equal to the ratio of this length to that length. So the ratio of CD to BD is equal to the ratio of CE to BE. So let's write that. So the ratio of CD to BD is equal to the ratio of CE to BE. And we can rewrite CE. We can rewrite CE as the length of BC minus the length BE. So CE is equal to BC minus BE, and BE is still BE. And then we can rewrite this expression as BC over BE. BE minus 1. And we see here that we remember that ABED is a parallelogram. So the length of BE is equal to the length of AD. So AD is equal to BE. So AD is equal to BE. So we can substitute AD into BE here. So this is equal to BC over AD minus 1. And we know what this is. Because the question said that the ratio of BC to AD is 9 to 5. So BC over AD will be equal to 9 over 5. So this is equal to 9 over 5 minus 1, which is equal to 4 over 5. So we get that CD to BD, CD over BD is equal to 4 over 5. So CD over BD is equal to 4 over 5. And we also know what BD is equal to. The question said BD is equal to 1, and CD over 1 is just CD. So we get that CD, the length of CD is equal to 4 over 5. There we have our answer. And we look here, we get that the answer to this question is B, choice B, 4 over 5. Sweet, we got the right answer. So basically in this video, we just drew some imaginary lines and we made an angle bisector line because we observed that if we have 46 degrees, we're going to get 23 degrees here. So we kind of saw a clue that that this problem will involve some kind of angle bisector thing. So yeah. So like this is one way of using the angle bisector theorem to elegantly solve a geometry problem. So, hope you understood this video and enjoyed it, and see you in the other geometry videos.